This conference will now be recorded.
Yeah, yes, we can hear you.
Okay. A very good morning, guys. This is Suresh, your trainer. Let's get started. I think we have waited enough time for others to join. Whoever wants to join, they can join while the session is going on. Anyone here from my previous batches?
It's me, Suresh. Uma.
Hi, Ma.
Hi.
Cool. Are you planning to join this batch as well?
Yeah. One of my friend, Sudha, I recommended this course to her.
Okay.
So yeah, we'll see how it goes.
Cool.
Yeah.
So today I'm going to discuss about our course and we'll walk you through what I'm going to teach you for next couple of months. Okay, and then I'm going to introduce what exactly this technology is, and then I'm going to walk you through different roles of this technology, and then I'll be taking your Q&A, question and answers. Okay, so let's get started, guys. Big data on cloud. Okay, so just to give you a glimpse of technologies what we are going to use to justify our title, I'm going to use Azure, okay, to deploy our big data application. So there is something called as Databricks, using which you'll be learning our course. Okay, so first things first, let me define what exactly big data is, and then let me explain what cloud is and how cloud helps us to deploy these big data related technologies, and then I'm going to walk you through the course that will make more sense. Okay, let's try to make this session as lively as possible, guys. I want every one of you to interact, right? Ask more and more questions. Okay, there are two ways you can communicate. Either you can unmute yourself and you can talk, or you can also use the chat window. Okay, so before we jump on to what exactly big data is, let's start with data. What is a data, guys? What is a data according to you?
Information about anything.
Mm-hmm. Any other answers? Okay, so what is information?
It's about what and how do we organize it properly to read it back or
Mm-hmm. Okay, let me explain. So basically, we use these terms, data and information, in the wrong context in our day-to-day life. Okay, so I don't want any textbook definitions, guys. But as long as the definition is correct, we are good. Now, according to me, data is nothing but a collection of some statistics. Collection of some statistics or attributes or numbers. Sometimes people just refer to data as numbers. When I say numbers, they need not be numericals, but any attributes. Okay. So for example, you talk about employee data. So typical employee data will have employee ID, employee name, employee role, employee location, and then department in which he is working for, the project allocation, his appraisal details. Okay, so all these attributes contribute to employee data. And then if you want to talk about sales data, in sales data you'll have the transaction ID, and then the product which he have purchased, maybe the price of that product, and then quantity of that product, and total selling price, so on and so forth. Okay, So this is what we refer to as data. Maybe you take students data. What do you have there? Student roll number and then student name and the marks he secured in all the subjects and then total percentage. Okay, so this is what we refer to as data. Okay, it's nothing but collection of some attributes or numbers or whatever it is. Again, depending on whether it is attributes or depending on whether it is numbers, we call them with different terminology. I don't want to get into it right now, but yeah, in our course we'll get to learn. But yes, data is nothing but some details or some attributes or some numbers, right? And then information. Okay, with the background I have given you, I would define information is nothing but the useful data. Let me explain. Uh, one request from my end, guys. I'll be giving you time to ask questions. Okay. The reason why I have told this is when you ask any question, you will not be able to see it, but on my screen, it will be displayed in the middle. Okay, which would interrupt me from the ongoing topic. So my humble request is to keep your questions with you. I will spend enough 15 minutes time to take your question and answers on course, but anything related to content, please feel free. After every topic, I'll be giving you a couple of minutes time to ask your questions. Okay, anything related to course, please keep your questions for the end of the session. Okay, and since you have asked this question, Harish, um, the course would be only on Azure. And like I said, the course would predominantly deal with big data, not with cloud. Okay, so we are going to use cloud just as a platform to deploy our big data applications. Hope that answers your question. Okay, now let's get back to the definition of information, guys. Yeah, information is nothing but useful data. Let me explain. You take students data. Let's say you went to a college and then you want to know about a particular class. Okay, maybe if the class teacher or someone have provided you with the student mark list, you'll not be able to make anything from it. Okay, just by looking at the students, at least at the first glance, you'll not be able to make anything. Okay, you'll see some numbers, you'll see some student names, you'll see roll numbers, but like I said, you'll not be able to conclude anything there. Okay, now let me take the scenario 2. In scenario 2, if the class teacher gives you some analysis sheet or maybe some aggregated metrics like the average of that particular class is 70%, and then the standard deviation is some xyz, and then some other details. Okay, now this is where you would be able to infer something. If the class teacher tells you the average is 70 point maybe 50, what does that mean? If you pick up a student in random in that particular section, his average would be around or the total would be around 70. Okay, it could be plus or minus 5 or it could be plus or minus 10 depending on the extreme cases. But if you pick any student, most of them will have their percentage around 70. Okay, so what does that mean? It's a good class, it's a good section, because the average percentage in that section is 70. These are the things which would let you take some decisions. This is what we refer to as information. Here I have given you a pretty basic example, but if you get into retail domain, you will be doing a lot of analysis on your data, try to understand things like what are the most sold items in a particular region in a particular season, uh, because depending on the region, depending on the season, the sale would definitely gets influenced. Okay, not just that. Maybe if any one of you are joining from India, or if you have heard about sales here, especially e-retail sales, e-commerce website sales, Amazon Great Indian Sale or Flipkart Big Billion Sale. Okay, they do a lot of analysis from the data what they already have in order to provide the offers where they can end up getting a win-win situation. Win situation for customer as well as win situation for the retailer. Okay, if you are from US, the same thing happens with same thing happens for Thanksgiving Day. So they don't just randomly throw offer, guys. They would throw offers, or they would decide on offers and the amount, I mean the percentage of offers and then bank offers. All these comes after a prolonged analysis on the data they already have. Okay, and the conclusions what were made after analyzing your data is what we refer to as information. Okay, so you might have heard about different data roles, like data engineer, data scientist, data analyst. Maybe you might be interested to know what they exactly does. So our day-to-day activities would always revolve around extracting information from data. This is what we do, and we provide this information to the business. So for example, you're working for banking domain, you will be doing a lot of analysis and you would be extracting information and providing that to business so that they can take their decisions, and you know um, they can strategize their business they can strategize their methodologies. So for example, going forward in the next quarter or maybe in the next half year, what are the different strategies that needs to be implemented, how we are going to get into it. One such successful strategy followed in India is sale day. Okay, so throughout the month, sale for a particular product wouldn't be available. They would be scheduling a particular time, particular product, and sale goes live, and they'll have a limited quantity for that sale. Okay, maybe 1 lakh products or maybe 1 million products they would be selling in that particular duration, and on a first come first serve basis, which would create a false hype for that product. Okay, and how they were able to come up with such strategies, because they have seen something called as surge for purchase of a product during the launch time. Okay, so they thought of we can increase that surge or increase that urge of customers to buy that product by having the environment of sale. Okay, so earlier it used to happen only for MI phones in India, but now MI and OnePlus as well. But now for every phone, for every stupid phone, they'll have the sale live. I don't understand. Okay, so all these strategies would come after a thorough analysis of the data they have. Okay, so like I said, our day-to-day activities would uh, involve in extracting information from the data. Okay, now what are the different roles that involve in this process? So there are a lot of roles, guys. One is data engineer. Two, I would be emphasizing on two such roles. One is data engineer. Okay, and the second role is data scientist. You might also have heard about someone called as data analyst. Will get to that role as well. Okay, now let me explain how these guys work. Data engineer is the one who provides data in a format that is consumable by your data scientist or data analyst. Data analyst. Let me explain. Okay, let's say I'm working for Amazon, and maybe in next couple of months they are planning for a Great Indian Sale. Now these data scientists will have a lot of domain knowledge. When I say domain knowledge, they would be knowing in and out of how a retail business works or how a e-commerce retail business works. Okay, so um, in order to come at some conclusions, they would be calling us, and they will say, I want this data, I want this data, I want this data. Okay, maybe XYZ, 3 data sets, and then your X data will have a particular format. Maybe, you know, they would be needing some 15 attributes or 20 attributes or 100 attributes, doesn't matter. They would be providing the format in an Excel sheet to you. Okay, like you being a data engineer, now it's your job to get that data in the format requested by the data scientist. You have to do whatever it takes. Okay, so their existing data set could be residing on AWS. Their existing data could be residing on you know, some RDBMS tool, maybe in their traditional SaaS systems, or maybe they might procure data from some third-party tools, okay, where the data would be shared from SFTP, or maybe their data could be residing on their SharePoints, whatnot. Okay, you take any source, okay. So now your role is to get the data to one single platform and then aggregate them and then provide it to the format that is requested by the data scientist. And at the end of the day, whatever the data you provide would be consumed for AI or BI. AI or BI. Okay. So when I say AI, it's artificial intelligence. So your data scientists would be running machine learning algorithms to understand the patterns, to understand how the sales are going on, or to understand what products need to be sold first. Okay. So there are a lot of things that would come into picture. And then talking about BI, BI is nothing but business intelligence. So we do have BI tools like Tableau, we do have business tools like Power BI, MicroStrategy, whatnot. Okay, so they will be using these BI tools to visually represent the sales trends, okay, or whatever they want to represent. Okay, um, maybe they want to create a sales snapshot which can give you end-to-end picture of how the sales are happening for every single product that is there in your platform. Okay, so everything would be visually representative, because at the end of the day, presentation matters. Business cannot understand the data on Excel sheet or data on file. Okay, so they would be able to easily understand when they are visualized. Okay, if anyone coming from a typical data background or a typical you know, data engineering background or data science background, you know, you would be understanding the importance of these BI tools. Okay, so this is what we do. Now, talking about data analyst, this data analyst is the guy who would be taking care of this BI part. But in modern days, I mean, in recent days, the role is being played by data engineer or data scientist. Again, it varies from company to company. Not every organization work in the same way. Okay. So for example, if you take me, I'm capable enough to do the data engineering part. I'm capable enough to do the BI part as well. Okay, so I have my certification on Power BI. Yes, I would be able to create reports on Power BI. Okay, same thing with data scientist as well. Sometimes data scientist would be able to create the BI stuff, because he will have thorough understanding on the domain. Right. Now, these are the roles, these are the terminologies they which are existing even before the big data came into picture. These are generic data roles, these are generic definitions. Okay, now let me talk about big data, this term called big data. Okay, so what exactly is big data, guys, according to you? I mean, your guess or whatever. You might have heard about this big data a lot of times. So what is your understanding of big data? Okay, let me explain. So big data is not something new or not something different from data. Big data is also nothing but a data which is having one of these characteristics: volume, variety, velocity, and veracity. Okay, now let me explain. So to put it in a simple terminology, big data is nothing but the data which cannot be handled by your traditional data management tools. Let me elaborate. Okay, let's say I have a RDBMS tool, and the capacity of that RDBMS tool is 500 GB. Now 600 GB or 700 GB to that RDBMS tool would be big data. If your RDBMS tool is capable of handling only 1 GB, again, the capacity of the data handling doesn't depend on your RDBMS tool, but on the server in which your RDBMS tool is installed. Okay. So let's say it is capable of handling only 100 GB of data. Okay. Then even 150 GB can be big data for your server. Okay. You take your phone, even 50 GB of data for handling would be big data for your phone, mobile phone. Okay. So any data which cannot be handled by a particular system can be considered as big data to that particular system. Big data big data doesn't have any thresholds, guys. Okay, big data need not always be in petabytes, always in size of terabytes. Okay, sometimes we deal with MBs of data as well. Okay, because we don't have robust systems built for handling semi-structured data. Okay, so when it comes to semi-structured data, people often consider big data as a good alternate. Okay, not just semi-structured data. You want to build a quick and dirty solution. Again, big data would let you do that, right? So there are a lot of advantages. Now, talking about characteristics, if you have any of these characteristics, volume, variety, velocity, and veracity, that data can be considered as big data. When I say volume, huge volumes of data, self-explanatory. Okay, and then variety, types of data. Okay, so I haven't yet introduced types of data. So talking about types of data, we have three types of data. Okay, I mean there are different classifications, but the variety characteristic here is defined on this classification: structured, unstructured, and semi-structured. Structured, your data is stored in rows and columns in a table format, and you can use SQL, structured query language, to query your data. Unstructured, any text files or your HTML data or your um, you know data which doesn't have any structure attached to it. Okay, it could be a PDF file, it could be images, it could be your video files, it could be anything which doesn't have a structure attached to it. Yes, that can be categorized as unstructured data. Talking about semi-structured data, it will have structure attached to it, but it's not typically stored in row columnar format or tabular format. It has a structure attached with it, but it's not typically stored in your tables. Examples could be your .csv files, .tsv files, and then the JSON format and XML format. All these formats can be categorized as the unstructured data. Okay, so if you guys are new to these data technologies, don't worry about what I'm talking right now, guys, because we have a dedicated session where we'll be talking about classification of data. Okay, for time being, I'm gonna give you a walkthrough of, high level walkthrough of all these things so that you would appreciate our course. Okay, so that is the reason I'm covering these things before I actually walk you through the content. Okay, so all the topics, whatever I'm discussing now, we will be deep diving into them once we start our course. So don't worry about that. Okay, so talking about variety, structured data, you have RDBMS to deal with it. Unstructured data, you have no tool which can deal with it. Semi-structured data, though you have some tools, but they are not as flexible as your big data stack. Okay, and the next thing, velocity. Velocity is nothing but rate of data generation. the rate at which the data is getting generated. The rate at which your data is getting generated. Okay, so velocity also plays a vital role, guys. You might have heard about streaming data. So streaming data is nothing but continuously generated data. Maybe if you take sensors continuously generate data. Okay, maybe you take IoT sensors, you take any other sensors, maybe every 5 seconds they generate data. You have OBD sensors in your vehicles. When I say OBD, on board diagnostics. Okay, so in recent day, every car is getting equipped with OBD devices. Okay, which would help you to understand your car performance, not just car performance. Uh, these days, these OBD devices are also used for enhancing the safety. Enhancing the safety. I don't know how many of you have heard about this example. You know, one of my colleague is owning a Skoda car. Okay, Skoda Kodiaq. Okay, now one day he was telling us that particular feature where he was driving on Outer Ring Road in Hyderabad. I am not sure how many of you know about Outer Ring Road. Outer Ring Road is a 4-lane highway kind of thing where the speed limit is 100 kilometer per hour. Okay, so people would be using that as a racing circuit or to test the performance of any new car. Okay, so after the office he is leaving leaving to home, and you know, at some point he got a beep sound from his car. Okay, and when he tried to check what was happening, he realized he almost slept for 10 minutes in car. He almost slept for 10 minutes. Okay, and then he got a message on his dashboard saying that take a tea break. Okay, how was his car managed to get that insight? Because of his driving patterns, because the kind of you know movement he is following is similar to a sleeping person. So a lot of analysis have happened internally, and like I said, what has made this algorithm detect whether he is sleeping or not? It's the OBD device, because it captures your driving patterns, the way you accelerate, the way you turn, the way you shift gears, the way you modulate your speed. All these things can be captured using OBD data, okay, or OBD devices, right? They continuously generate data when your car is running. You know, if it is a straight road, every 5 seconds you get a data point, and if it is a covered road, every second you get the data point. Again, it might vary, but most of the projects I have worked on in automobile industry, yes, this is the pattern. Straight road every second, sorry, straight road every 5 seconds, curved road every second. Okay, and not just this, your mobile have a lot of sensors these days. Whenever a word smart involves, they are equipped with a lot of sensors. Okay, so data that is getting generated from sensors can be categorized as streaming data. Okay, and now you think about the rate at which they are going to you know, generate data. Okay, so that comes under velocity. That defines the velocity, the rate at which the data is getting generated. And not just that, your web streaming data, clickstream data. So what is this clickstream data? Whenever you have visited a website, for every single click you are making in that website, you will end up generating data in the backend. That's how Google is able to display ads when you jump onto another website. Okay, that's how your smartphones are able to show you the same ads what you have visited earlier in every single blog you go or every single app you open. Okay, so you there is something called as Google Analytics. I don't know how many of you have heard about it. Google Analytics is a component which comes along with your G Suite account. Okay, so for example, you have deployed your website, you can integrate your website with this Google Analytics. At the end of the day, your Google Analytics platform would give you every damn information about your website, like how many users have opened your website and whatever they have clicked from your website, and if you are displaying any streaming videos there, how many of them have watched the complete video, and then their Gmail IDs, whatnot. You will get every single information about the visitors of your website. Okay, and most of the blog writers who would create blogs for earning purpose, they would find this information pretty helpful. Okay, so not just Google Analytics, guys. You can also do that tracking. Everyone does that. Everyone does that in order to generate leads. Okay, for their products. Even that comes under Velocity, because you never know how many users would be landing on your website and using your website. So to capture that data, store it in your infrastructure, not going to be really easy, guys, with the traditional tools you have. Okay, and the final thing, Veracity have been a recent addition, I would say. So I have never seen any dataset which has Veracity as a feature in my real-time projects. But let me explain, because most of the time you refer to textbooks and you refer to blogs, right? Veracity can be considered as data in doubt. Data in doubt. Okay, so in this data era, I mean, this era is what we refer to as data era, because there is a lot of data that is available. There is a lot of data that is available. Okay, so this variety, I mean, what data to trust and what data not to trust, and then whatever the data you are getting, the authenticity of the data is what is referred to as veracity. Okay, you have so much of data and you don't really know the authenticity of the data. That data can come under the veracity. Okay, so any data which is having any of these characteristics, it could be one or more characteristics, but if it has any of these characteristics, okay, it can be considered as big data. Okay, now going back to uh, big data and the operations we can do on it. Not just big data, any operation, I mean operations on any data. There are two operations, guys. One is storage and the second one is processing. First things first, you are getting this data, that's fine, but at the end of the day you'll have to store it somewhere so that you can use it later. Okay, so storage comes first and then processing. Okay, what is processing? Any operation you do on data after its storage, be it reading or be it writing a query or be it doing some analysis, all these things would come under processing. Okay, now Hadoop is the technology which initially started for managing big data. When I say managing, Hadoop provide the huge set of tools which would help you to store big data and process big data in a distributed fashion. Again, when you're dealing with any of these characteristics, be it volume or velocity or variety or whatever, okay, so definitely you would expect an improvised system in terms of performance and in terms of features as well. Okay, so the same is delivered by this Hadoop ecosystem. Okay, it would let you store your data in a distributed fashion, not in a single machine but in multiple machines, and all the challenges are taken care of on data availability or any other thing. Okay, so it will always make sure that your data is available because it stores 3 replicas of your data. Okay, so there are multiple such features. Okay, just to give you one example, yes, it will always make sure that your data is available. And how it does it, it maintains a replication of 3, or every day, every file you store, Hadoop would have 3 copies of it. Okay, now yeah, talking about the storage, Hadoop has provided us with something called as HDFS, Hadoop Distributed File System. And for processing, initially it provided MapReduce. Okay, And after that, a lot of processing tools have come into market based on this map reduce, like Impala, Pig, Hive, whatnot. And then the recent sensation is Spark. The recent sensation is Spark. Okay. Now, cloud versus on-premise clusters. Now that you want to set up a big data environment, guys, now you understood what is big data, what is data, and then you understood what components you would need to store your data and process your data. Now, in order to set up your own cluster, okay, what do? Maybe I am starting a company and I want to set up a big data environment in my company. Okay, first things first, I'll have to procure infrastructure. Maybe based on our analysis, we do a lot of brainstorming sessions in order to understand how much data will get generated and what infrastructure we need to go with to meet our at least 5-year requirements. Okay, so now I would go ahead and procure the infrastructure, maybe 10 machines, 10 high-end machines, and then install Hadoop on it, and everything related to the maintenance will be handled by the folks in my company. Okay, so for every single thing happening on this environment, you know, the administrators in my company are responsible. I need to take care of a lot of things. You know, if my storage, if I'm running out of storage, I might have to buy another machine and increase my storage there. If something went wrong with my infrastructure, my administrators have to take care of it and you know, fix it, make sure that data is available. Not just that, guys. There are a lot of pain points, but you might have understood by now. Having it with you and maintaining it and you know, um, improving it when you're running out of resources, everything is handled by you. Okay, now talking about cloud, what is a cloud? Basically, cloud is nothing but someone's computer. Cloud is nothing but someone's computer. Maybe I want 500 GB disk and maybe 8 GB RAM and 2 cores or 3 cores for my day-to-day activities, or maybe to develop some application. I don't really need to own a laptop, but I can rent someone's laptop. Again, do I need to rent the physical laptop? Not really. Okay, so what he will be doing is he will have infrastructure at his home, and he'll build a beautiful web UI using which I can access his resources. Okay, now all I need to do is I will have to pay him and get access to that web UI, and using from that web UI and from that web UI I can access the infrastructure that is sitting at his house. That is what we call as cloud. So the same is the case with AWS, the same is the case with Azure, the same is the case with Google Cloud Platform. Okay. Now, when I deploy my big data related tools on cloud, you know, what are the things we talk about? What are the challenges we talked about? I don't really need to take care because the vendor is responsible for that. Okay, he will make sure that your infrastructure is up and available 24/7, 365 days, and then he is responsible for data availability. And maybe today your requirement is 1 TB, and tomorrow if it is 10 TB, yes, you can easily scale up your environment. Okay, just by paying some more to him, some more bucks to him. At the end of the day, that is all needed. So you can easily scale up within a matter of minutes, guys. Okay, and then maintenance cost, and then your team maintenance cost, everything will be cut down. Okay, so that's the beauty of using cloud. That is the reason most of the industry today is moving towards cloud. Not just in big data space, guys, in even in other tools or other technologies, they are moving towards cloud. So cloud, again, depending on the type of service you use, there are multiple services. You might ask me, boss, does cloud provide only infrastructure? It depends on what service you choose. Okay, so there are different cloud services like infrastructure as a service, platform as a service, software as a service, whatnot. Okay, so again, we will be talking about that in our course, like what exactly these infrastructure as a services, platform as a services, and software as a services. But for now, let's confine our discussion to infrastructure as a service. Okay, so you go and procure some infrastructure, access that infrastructure using a web portal, and then deploy your applications in that infrastructure. Develop and deploy your applications in that infrastructure. Okay, so this is how cloud would help you guys. Okay, and three front runners for three prominent cloud providers right now in the market are Amazon, AWS, and then Microsoft Azure, Google's GCP, Google Cloud Platform. Google Cloud Platform is a recent entrant, so you can just rule that out from our discussion for time being. And other two front runners are Amazon AWS and Microsoft Azure. If you ask me, boss, among these two, what would you suggest for future? I would just close my eyes and tell you Microsoft Azure. Okay, so why not Amazon AWS? Because Amazon AWS has been into the market for quite some time now. When you compare between Amazon AWS and Microsoft Azure, Microsoft Azure uh, is the recent entrant. Okay, I mean in between these two. Okay, but I can still say that Microsoft Azure would definitely take over Amazon. I would say it has already taken over a lot of business which Amazon used to have earlier. Okay, so the only reason is the kind of environment they have built up. There are a lot of advantages which Microsoft Azure is providing. And all this happened after Satya Nadella has taken over Microsoft guys. I mean, Satya Nadella has appointed as CEO in Microsoft. He has invested a lot of amount on cloud development. Okay, and one such investment is Databricks. Databricks is heavily backed up by Microsoft. Okay, but if you ask me, boss, is Databricks not available in AWS? It is available in AWS. Couple of months back, it has been added to Google Cloud Platform as well. Now, Databricks environment is available in all the cloud platforms. Okay. Now, like I said, Hadoop started with MapReduce and then came Hive, which ruled for few years. Right now, it's Spark trend. So Spark is the technology. Spark is the big data technology which is trending right now in the market. Okay, and to run this Spark, we will be using a tool called Databricks. We call it as distribution, and we run this Databricks tool on Azure. Just summarize our course, guys. We use Spark. I mean, we will learn Spark. We will learn Spark on a tool called Databricks or a distribution called Databricks. And to deploy this Databricks, we will be using Azure Cloud. As simple as that. Okay. Now, what you are going to learn? First couple of weeks, we will be spending some time on learning Python basics, which is very, very important for developing Spark applications. And then I'm gonna walk you through cloud environment. So though we are using cloud only for deployment purpose, but it is required for you to know what actually cloud does. Okay, so at least you should be understanding what exactly cloud is and then different services that are available in cloud. Just because you are learning Azure, you should also have some knowledge on what are the services provided by Azure. Okay, so these things I'll be focusing maybe for a couple of sessions or 3 sessions we will be spending there to understand this thing. And it is also important to understand what are the different features AWS provide, what Azure uniquely brings to your plate. Okay, and also GCP. So we will be spending some time over there. And then I'm going to walk you through Databricks environment. Then I'm going to use, sorry, you will be learning Spark Core. Okay. So nobody is calling it Spark Core now. If you go to Spark documentation, it's called RDD programming concepts. Okay. And then Spark SQL. Here you will get to learn about data frame, different data frame operations, and then optimization techniques for storage like partitioning, bucketing, and then you will get to learn about different file formats, Delta, Parquet, and then Avro, row file formats, column file formats. Okay, so everything would be covered here. Okay, so at a high level, these are the topics which you are going to learn during our 2-month course, and the detailed content coverage is given in the syllabus document, guys. Okay, and then I'll be sharing my real-time experiences. I'll be sharing my project experiences. Okay, my interview experiences, and then we'll have some exciting workshops coming up. Okay, so during this Python, I'll be conducting some workshops, and then before we start Spark SQL, we will be doing some workshops on SQL. So if you are new to some technology, you don't really need to worry about that. We will make sure that you are taken care of. Okay. Now, like I said, in a span of 1 hour, I'll not be able to cover everything, guys. Okay, I have tried as much as possible to cover what is required for you to understand this course is all about. Okay, at the end of the course, you will have all the tools equipped with you to do the data engineering. Okay, now let me spend some time for taking your questions. Now, please go ahead, guys. You can ask your questions related to course, or you can ask whatever you have in your mind.
Basically, is Spark a kind of a SQL or something, processing data kind of thing on Databricks?
Spark also supports SQL kind of. Okay, so basically Spark is a framework. Spark is a framework which would help you to process your data in a distributed fashion.
Mhm.
Okay, it has its own way of processing its data, but yes, you can process your data also by using SQL called Spark SQL component. You can write Python code, you can write, it's basically a framework.
Mhm. It is
Okay.
basically used in that example you have said, like, for example, we browse something and we keep getting those advertisements. Such kind of things will be done by this?
No,
Mm.
Spark SQL doesn't help you to do that. Spark SQL, I mean, once you have the data with you, then you can, process the data using Spark.
So what exactly is process? Like, what do we do with this Spark? So,
I would say any analysis on your data,
okay,
any
who will use
analysis.
that? Who use that analysis data? Like,
Just give me a second.
uh-huh.
So I have a question like this Spark. Okay, this you said it's a framework, right? Okay, does it support only Hadoop Hadoop system, or it's like it support any relational database like Oracle or any other system?
Yes, Sudha. Sorry about that. Yeah, talking about Spark, and you asked me who does that analysis, right? Like I said, data engineer is that guy who would get your data. Okay, and talking about your analysis, I'm just thinking, how can I answer your question in an understandable way? in a layman terminology.
I mean to say, what is the output? Basically, do they give any reporting kind of thing or
Nah. Your role would give you a data set again, your final data set, the format which can be
format?
consumed by your data. Say, for example, you talk about any reporting tool. So you cannot just consume your data like that. It has to be in a dimensional model for better consumption of your data, be it a star schema or be it a snowflake schema, depending on the variations you have. So where you have your facts divided, you have your dimensions divided. Okay, and
Yeah.
then you might have your data divided into different data sets. Say, for example, in our project, you know, we have our enterprise data which we get from our warehouse, and then to understand our competitors how they are performing, we also procure data from third parties. Okay, there are a lot of third party guys from whom we can purchase data. We get our numbers as well as their numbers, because we will be doing business through them, not just us. I mean, we are basically a financial organization. I work full time for a financial organization. So not just our organization, any other financial organization do their business via these third party tools. We call them as brokers or broker firms. Okay, so we procure a lot of data from these broker firms. Okay, in addition to that, in addition to that, we have our GA data, Google Analytics data. We have our own platform, and these Google Analytics folks, we are paying them to have our consolidated data, where they'll provide us with activities. We call that as activities data. Okay, so in order to do analysis, in order to run some algorithm, you need to stitch all this data together.
Okay.
Okay, so that is what we call as wrangling, data wrangling. Okay, or data engineering. I mean, there are a lot of posh terms which are used for the same thing. At the end of the day, you will write SQL queries in order to get the data in the format you need, and finally store it in a table.
Oh.
Okay, your BI folks or AI folks can consume your data directly from the table. Okay, it could be one table or it could be multiple tables. Like I said, star schema, snowflake schema, your data would be stored in multiple tables. Or it could be a single table with all these columns in a columnar format, like Parquet. Even that would also give you some good performance. Basically, you are trying to build a central repository for all your AI and BI needs by taking your data from all these sources. Make sense?
Okay. Yeah. Thank you.
Yeah.
Hi Suresh.
Hi Ganesh.
What is Databricks? Hello.
Sorry.
What is Databricks?
Okay. So on what technology you're currently working on, Ganesh?
I'm working on like a full stack developer.
Okay, full stack developer. So you use Java?
Yeah, Java.
Okay. In your language, Databricks is similar to Eclipse.
Okay, it's IDE.
It's not IDE. It's similar to. So how does Eclipse help you to build your full stack applications? Similarly, Databricks would help you to store and process your data. It's a distribution basically.
Okay.
Okay. So just like an RDBMS tool, you I think since you're working on full stack, you should be having knowledge on RDBMS as well. So if you want to store data in table and if you want to process your data using SQL, how do you use an RDBMS tool? Similarly, you use Databricks tool to write and deploy Spark applications.
Okay, got it. And one more thing, Suresh, like on what basis we can say like Azure is better than AWS? So because even AWS also spending the money on Databricks, right? So in future, like how it will be when compared to AWS and Azure?
Okay. To answer your question shortly, integrations with multiple tools. So there would be a lot of enhancements that were being made to Azure tools. So for example, you talk about Power BI, you talk about Power Automate. Have you ever heard of this tool called Power Automate?
No, I haven't.
Okay. Let me ask you another question as well. What mailbox you are using in your company, Outlook or anything else?
Outlook only.
Outlook and Teams, right?
Yes, correct.
Okay. So there is this tool called Power Automate and then Power Apps. You would be having license for these tools. Just give it a try. So there would be many tasks which we do manually. Okay, maybe sometimes files would be shared over a mail, or maybe any changes that needs to be done would be shared over a mail. Okay, so what we do is we manually download that file and then either upload it to SharePoints or upload it directly to Azure. When I say Azure, it could be any cloud. There is this tool called Power Automate, which would help you to connect all these dots which are being done manually. I'm not saying Azure is preferred just for the Power Automate, but there are many such tools as Power Automate which would make your life pretty easy. And then talking about DevOps, okay, what are the DevOps operations you do, all the CI/CD flows, they are internally built in Databricks. You don't really need to take care of version control. Okay, again, I'm talking about Databricks here. Let's not go to Databricks, but yes, all that advantages also you have in Databricks. And talking about Azure, the first thing which made Azure as a competitor for AWS is dividing compute or the storage. Okay, you will be paying separately for compute, you will be paying separately for storage, which was not the case earlier for AWS. But I have heard that AWS is also uh, came up with the similar approach, but I'm not sure because I'm not an AWS guy. Okay, but yes,
Got it.
that's one feature which made Azure a rock star. So you want see, I'll give you a simple example to understand what is this storage and compute thing. Okay, so let's say you want to store 1 petabyte of data. Okay, and when you want to buy a laptop having a petabyte of data, you would also get the matching configurations to process petabyte of data. So you will be getting some i7 processor, you will be getting some 32 GB or 64 GB RAM. So it comes with such kind of package. But talking about your requirement, you only need storage 1 petabyte, but you don't really need such huge computing power. For your processing, maybe i3 processor with 6 GB RAM will do. Okay, but you are buying all the unnecessary resources just because you need 1 petabyte of storage. Okay, so what should you do? You should be buying a laptop with 1 TB hard disk or 500 GB hard disk, which would give you enough compute services, and then you buy an external hard disk of 1 petabyte. You got me right?
I got it.
Okay,
Yeah, we'll
so
buy
this
the
feature,
external hard disk only.
yes, so this feature have made Azure a rockstar. I mean, at least after the introduction of this feature, it has gaining its market, because you will pay for how much ever store, because at the end of the day, always storage is cheaper, hard disk is cheaper than your RAM. Hope that hope that makes sense.
Understand.
Hey, hi Suresh. I have one question.
Hi,
So,
Prem.
yeah, does Spark supports a complex transformation, or it's just loading the data from a table from different source to different source?
When you say complex transformation, what transformation are you referring to? You can do pivoting and pivoting also using Spark. And I would say there is nothing Spark can't do, because you don't really need to stick to SQL every time. You can write your Python code, Okay, whenever a tool is supporting a programming language, I feel there is nothing that a tool can't do.
Okay.
Okay, like I said, even pivoting and unpivoting can also be done in a single step. Are you aware? Not aware. Have you ever worked on pandas?
No. Suresh, mainly
Python
actually,
panda?
basically, I'm actually working as a ETL consultant, like okay, mostly Informatica side. Okay, so I mostly work with the RDBM, BMS, and that is with the SQL mostly.
Excellent, excellent. So tell me one complex transformation which you feel is the best you have done so far. I'll tell you whether it can be done by Spark or not.
So, like one example, like okay, so we used to fetch from the multiple sources, that means multiple tables, and we join with the different joins, and then okay, we do that union and sorting and all these combinations. Okay, we will do it Informatica level and through the SQL.
Can be easily done here.
Okay.
All these operations. Even in my case, there is a use case where we have to create a customer journey. Okay, so how the association of that customer has started with our organization, and how it was going. You can go through it, like we call that as customer journeys. Okay, digital marketing terminology. This is the use case where we literally have joined 15 tables.
Okay.
Okay, because your data would be at multiple stages. Even after he get into the enterprise level, there we will have multiple stages of interaction with our sales folks, with our marketing folks. Okay, so even like I said, pivoting and pivoting, for me, join, union, they're all nothing. They're just a basic operations. For me, the real challenge is when you are pivoting and unpivoting your data. Okay, so even that can be handled very easily. Not just that, your data format, even it is JSON, even it is XML, even it is any other format, Spark is capable enough to easily deal with it.
Okay, sure. Thanks. Thanks.
Okay. Any other questions, guys?
Suresh, initially I think the data stored in RDBMSs, later they moved to data warehouses, and now I think where we are in like in big data, Hadoop and all those things. Maybe in future it will be the data storage will happen. Like maybe some of the guys they started. I'm not sure. The cloud database providers and cloud data storages. In that case, how it will be big data with that cloud.
Let me explain. RDBMSs are not yet replaced because RDBMSs have their own significance, because Hadoop is not a good fit for transactional data. Okay, so we only do historical data analysis here. We only deal with historic data. Okay, I hope you are good with the classification historic data versus transactional data. Okay,
Yeah, yeah.
so still for transaction data, Hadoop is not a place. And again, for MDM kind of projects, Hadoop is not a place. Still, we kind of maintain our master data in Oracle warehouse, in our project at least. Okay, so these are the operations which I feel still Hadoop or big data environment or Spark is not capable enough to handle as efficiently as your RDBMS or data warehouse handles. But theoretically, Hadoop started supporting transactional data with Delta format. Delta is a recent addition. I would say Delta started an year ago, but have to see how far it will scale up with the transaction data. Okay, and same thing is the case with master data management as well. I still feel warehouse is a place where it can be done, but other than these two, for any other transformations or any other management, big data environment is the best. Okay. And then we'll talk about the storage. You said cloud storage. So right now people are relying on cloud storage. I'm not going to use HDFS. So when I deploy my Spark services on Azure, I would be using ADLS. Why should I use HDFS, which is on-premise? Okay. Similarly, if you are using, if you are running Databricks on AWS, you will be using S3 buckets. Okay. So in our course as well, we will be using ADLS for our data storage. Hope that answers your question, Ganesh.
Yeah, I got.
And Harish, to answer your question, I'm not able to hear you. If you are able to hear me, please ping your questions in your chat box. I'll answer. I'm still not able to hear you. I'm seeing you're trying to ask some questions, but unfortunately, I'm not able to hear you. Yeah. Guys, I think we are running out of time. To answer your question, Harish, we are not purchasing infrastructure as a service. This Databricks is going to be a platform as a service. So you will be getting it as a platform. But on-premise, yes, we will be running it on Linux. Yes, Databricks is a PaaS, PaaS. Yes, it would be same on AWS as well. If you want to run it on AWS, you are comfortable using AWS, please feel free, and you can practice on AWS. That doesn't make any difference.
Is Databricks specific to Azure, or we can use Databricks on Amazon AWS also?
You can use Amazon also. You can use it on GCP as well now. Uma, if you remember when we started your course, GCP doesn't support Databricks back then. Okay, I remember letting you guys
Yes.
know in the last session or penultimate session of our course, data GCP started supporting Databricks.
Yes, you mentioned in the beginning it was only these
Yes.
two, Azure and AWS, but then later you mentioned that GCP started supporting.
Yes.
Okay.
So it doesn't matter whatever the cloud you want to use, you can use. And Harish, do you ever log into a Unix terminal on Azure for Databricks? For Databricks, why should I log into Linux environment? I have everything on Databricks portal. So I can track my job, I can track the status, I can track my clusters, everything on Databricks terminal. So I never logged in. Because Spark jobs could be in Scala, Python, Java, etc. So asking if Databricks notebook is the only method of running Spark jobs. In Databricks, yes, notebooks are the only way of running your jobs. Okay. Writing Scala, Python, Java, they are all old school. So when there was no Databricks, or when Databricks haven't gained any prominence, okay. So I still remember the pain of developing a Scala code in IntelliJ IDE, wrapping it as a jar using Scala build tool, and then transferring that jar file to your edge node and deploying it over there using Spark command, Spark submit command. No, you don't need to do all that shit now. People are scared of big data only because of that process. Now you don't really need to do that. Creating a job and deploying it is a 2-minute job now. You can use Scala, you can use Python, you can use R, you can use SQL, you can write shell scripting on Databricks notebooks. I would use Python. Python have already replaced a lot of Scala applications. Any other questions, guys? Streaming is through Kafka, not through Databricks. Spark streaming code would be in Databricks. And again, I have to mention this, guys. Kafka and Spark streaming wouldn't be covered as a part of our course. Yeah, go ahead, Harish. While doing course, we only watch you do exercise on Azure, or we do it. I don't give you I mean, I don't give you separate time to practice. If you want to do it, you can do it parallelly, or if you want to do it later, you can do it at a later time. Okay, we will be providing you with the recordings. Yes, you have to do that. I'll be sharing Databricks notebooks, but only at the end of the course. Yes, whatever you see in this course would be shared. Okay, cool, guys. I have to leave. And next week also we'll have a demo. If you have more questions, please feel free to join next Sunday as well. Okay, and other course detail. How long is the course? It would be 2 to 2.5 months, depending on the questions you ask. If I receive same number of questions, it would definitely go till 2.5 months.
What are the timings? Will it be like 8:30?
Everything will be informed by our career IT folks, Uma.
Yeah,
Yes,
last
Suresh,
time.
sorry to interrupt.
Sorry.
Hi, this is Lakshmi from Career IT. And I'll be sharing those details the times and everything. I'll be
You are
sharing
breaking.
details in mail and in WhatsApp also. So regular will be on 22nd onwards. 22nd Monday.
No worries, guys. Actually, Lakshmi Garu is breaking up, but she will be sharing all the details with you regarding the course and timings. Okay. Anything related to course and other things, I mean, anything related to administration part, yes, you can get back to Lakshmi Garu from Career IT. Okay. Thank you, guys. Have a great day. Bye bye.